Hello and welcome to a new video. Today we'll discover this amazing equality, so let's get started. Well, firstly, on the left-hand side of the equation there is sine, the hyperbolic sine of this imaginary number. But what is the hyperbolic function in the first place? Well, the definition of the hyperbolic function sine h of x is the following. This equals to e to the x minus e to the minus x, all divided by 2. This is the definition of hyperbolic sine, and we will use it throughout the video. But we also have to throw the imaginary unit I in the picture. How can we do it? Well, we need to start with a very famous equation, the Euler's identity. And the equation is the following. Let me switch colors. E to the ix equals to cosine of x plus I, let me use another color, I times sine of x. We need it in order to get this equality. We also need sine of x, and we somehow have to take sine of x out of this equation, and we can do it in the following way. What if we replace what if we replace x with minus x? Let's see what happens. So in this equation we have to take x and we have to replace it with minus x. So let's do it. This becomes e to the minus ix, because we just put the minus in front of I. Then we have cosine of minus x plus I. We don't have to change the sign of I, we're changing the sign of x. Bear in mind that we're doing nothing to I, times sine of minus x. Now, some basic properties of cosine and sine turn out to be very useful, because cosine is an even function. This means that cosine of minus x is cosine of x. We can get rid of the minus sign basically, and sine of x instead is an odd function. This means that sine of minus x is minus sine of x. That being said, e to the minus ix, let me use this color, minus ix equals to cosine of x, so cosine of x minus, because we're taking the minus in front of sine, minus I sine of x. Now we can get rid of this equation in the middle, because we don't care about it for the time being, and we can move this equation up so you can see the difference between the two equations, the one containing x and the one containing minus x. Now, if we were to add these equations, we would obtain 2 cosine of x on the right hand side, but we're interested in sine, not cosine, so we can do something else. If we take a minus sign and just multiply the second equation by minus 1, this becomes minus plus. And in doing so, we basically have a plus sign here and a plus sign here. So we can add the two without getting rid of the sign, which is the term we're interested in. So let's add these two equations. E to the ix minus e to the minus ix equals to 2I sine of, let's use white for now, 2 sine of x. Now we can basically get sine of x on the right hand side by dividing the left hand side by 2I. So e to the ix, let's do it here without rewriting everything. So 2i here, and this equals to sine of x. Now we can do something else, because if we multiply the top and the bottom, the denominator, by I, this becomes I times I becomes I squared, but I squared equals minus 1, this equals minus 1, so we can get rid of I squared and just put a minus sign, and don't forget the I in the numerator. And this is the equality we were interested in. Now, we have to take the first equality we wrote today and compare these two equations. Well, there are lots of similarities, because this part here, this factor, is basically the same. The only difference is the exponents are the exponents, because here there is an imaginary number, so I that multiplies a real number, and here instead we just have real numbers. So the first thing we can do is to take the hyperbolic sign and give it the imaginary unit times x. So we just plug I inside this function. So we basically have to replace x with ix. So this then becomes minus ix. Now the two are very similar. The only thing different is this minus I on the left hand side, but we can move it again to the right hand side. So let's just move this minus I here, that becomes minus 1 over I. Again, if we bring the I to the numerator, we get a minus sign in front. So at the end of the day, this becomes an I, and I will put it in front of sine of x. Now these two are equal, so we can confidently say that I times sine of x equals to the hyperbolic sine of ix, and this is our equality. If you enjoyed this video, please leave a comment down below and subscribe to my channel, because in the next video we'll see something even more interesting. But firstly, we had to get this done and find this equality, otherwise we won't be able to dive into more interesting equalities and stuff. So see you in the next video. Bye.